Hi guys, welcome, and today we are back with one course which we are starting from today. It's an algorithm course. Not sort of a learning course. It's sort of like study plan that is provided by the lead code itself, called the 14 days to crack algo. So we are going to start this course from today. Like we are going to solve the problems daily since they have already scheduled like the day wise. It is going to be 14 days, so day 1 and day 2 and so on. So we are going to start this. I even recommend you to start simultaneously as you are seeing the video. It is more helpful for you. There are a lot of topic. It's a topic by questions like this is algorithm 1, next it will be algorithm 2 and algorithm 3. So there are three levels. So how to follow this consistently till the 14 days to be better in algo. So day 1 will be based on binary search, day 2 will be on two pointers, day 3 2 pointers, two pointers, sliding window, breadth first search and all that stuff, right? This is the algorithm 1. This is sort of an easy level. As algorithm 2, algorithm 3 comes, the difficulty will rise a bit. So I do recommend you to start with this course. So let's start with the first problem, that is binary search. It's an easy level question, right? So yeah, basically we all know what binary search is, and it's more I mean uh, time. It's not more time consuming, optimized code. It is, right? So it's easy. Let's do it. I am sure that most of you know what binary search is. So let's start with the binary search. So first, as we need a low and a high value. Low value starts from 0 and high value starts from num start size of -1, right? And we know that we will check the condition where L is less than or equal to H. I please do recommend you to start simultaneously as you are seeing the video. It will be more helpful, right? So just listen to the video and just start. Um, and int we take a mid variable, and I know most of you do write like this, right? This is not that optimized or more feasible solution. I do recommend you using h minus l, because in case they have given the large value, that time it might be a problem. So do go with this, because these two gives the same solution as if you do l plus h by 2, but this is more uh, easy when there is large values, right? Okay. So okay, you did this, and what is next? We just check if num of mid is double equal to t. If that is the case, just return mid, right? Else if we check if num of mid is greater than t, if that is the case, we say h equal to mid minus 1, else l equal to mid plus 1. That's it. That's it, right? So or else if we don't find, just return -1 as the question suggests. So let's run this. It should run. It's working, and it will be submitted too. Cool. So next problem. Let's jump quickly to the next problem. That is the first bad version. Basically, I have already written the solution to reduce the time. Basically, what they're asking is, they have you are the product manager and currently leading a team to develop a new product. So unfortunately, the latest version of your product fails the quality check. Since each version is developed based on the previous version, all version after a bad version are also bad, right? Cool. So what we have to find is we have to find out the first bad version, and there is a API already given. This API gives you if the version is good or bad, right? If it is it if it returns true, then the version is bad, right? Cool. So in this, they have given the five versions. In that, four. I mean, in this, the bad version will be four. Because I mean, it doesn't depend on us. The API just decides if it is bad or good, right? So they're asking the first bad version. See, till here the version was good, but after three, the fourth version starts becoming bad, right? Because of four, all the other version affects. So they're asking what is the first version that is bad. Return that. So it's a four, right? I hope you're getting. So we have to solve this using the binary search. We can solve this using just through looping it, but through using for loop, just checking the numbers. But we are doing it using the binary search. The basics are same. You just have to have to the help of the helper function, just returning. I mean, I will start from 1 because there is no 0 on this, so I'm starting from 1 to n. I will do a binary search. I'll say if it is equal, then just return L. That is, L will be our solution, right? And which we just do the mid. We calculate the mid, and if it is good, if I mean if this is true, if what does it mean if it is true? If that is true means it's a bad version, right? So what we do is we say we set high to mid. Why do we say high to mid? Because we know that if the bad version is true, we know that it will be before the that version itself, right? For example, from 1 to 3, if the version is good, that means if the API is returning false, then after 3, if it is returning true, we are pretty sure that before, I mean, if for example at 5, if you are getting true, that is it's a bad version. We are pretty sure that before 5 only, you we might get the first version where the affect I mean it was a bad version, right? But we know that after the mid, after that 5, we know that it's obviously going to be bad itself. So we have to set the I to mid so that we get the proper solution, and else we have to include mid itself because it's true. We don't know if that is the answer or not, right? So we set, even we take mid in, and after that we just say if it is good version, I mean, if it is not bad version, just set the low to m+1 because we know that it's not bad. So we just set L equal to m+1 and we return it. So L will be returned here, which will be the bad version. Simple. It's a simple binary search. The thing what we just implemented here, we are just applying it here. Right. Cool. So that's the solution. If we run this, basically, I'm not going in a lot of deep because it's an easy question, not that tough. Um, yeah, it's working. And next, let's come to search inserted position. Even this is a easy level question because we are using the same idea which we have used here. That is the binary search. See, even in this, what they are asking is they are given a sorted array and they have given the target value. Return the index if the target is found, or else return the index where it should be inserted. And whenever you see this, like write algorithm with O of log n, just blindly imagine it's a we have to use a binary search, and if they have given this sorted array also, right? They are given in, as I mentioned in the previous videos too, like if you do not check my pattern recognition video, I do recommend you to check that. In that also, when I mentioned that if they are given the sorted array, do think of binary search, because mostly it will be applied, right? Cool. In this, let's see the example one. In example one, they have given target 5. We know that in index 2 we find the target 5, so we return index 2. In this, they have given 2 target 2, but there is no value. So what they have said is, if there is no value, just return the index which should be where it should be inserted next. So after 1 it should be inserted, right? 2 should be inserted after 1, so we return at index 1 we need 2, right? So this is how we do. So we do for the even for this, as I said, we use binary search. We set low to 0, high to the this index, and we check if it is lower, less than or equal to h, and we find the mid, and we check if the mid is double equal to target. If we find the target, just return the mid, that is the index value. And else if we find anything greater than target, we know that it will not be after that mid, right? It will be before mid. So we just set high to mid minus 1 so that we don't go to that range. Or else, if we find that it is greater than, it's less than target, we uh, uh, we say L equal to mid plus 1. We L equal to mid plus 1. If we did not find, we return L, because we are looking for the lowest index, right? I mean the index which should be inserted after that, right? So for example, if you don't find 2, L will be the lowest index. L will be pointing towards 1, because we did not find 2. So we will return L, because now the mid will be mid plus 1, that is will be pointing index 1. So we return L, so that we return the required index. I hope you got the idea, and you learned something. And this is a basic binary search. It's an easy level question. I'm sorry I went too fast today, because it was an easy level question and it was a basic binary search. Yeah, I hope you all learned something and you are doing simultaneously too with me. Do like the video and do subscribe to our channel for more updates. Thank you. Bye.